Students, as you're aware, we are dealing with calorimetry problems, and this is a simple comprehension-based question. See, this is a question linked with graph also. So, good question. Definitely, we can do this. Now, let us study what exactly is given in this particular question. Right. You have a 0.6 kg sample of water and a sample of ice. You can see that. There is a conducting wall and entire surroundings means you can see this is all insulating. Nothing enters from outside into the system. But A and B are separated by a conducting wall. Water will not rush into ice or vice versa otherwise. Now, what is happening? You have two compartments A and B separated by a conducting wall in a thermally insulated, what do you call, container. The rate of heat transfer from the water to ice through the conducting wall is a constant. Note this point. The rate of heat transfer from water to ice through the conducting wall is constant until thermal equilibrium is reached. Good. There's one important data. Followed by another data here. The temperature T of the liquid water and ice are given in the graph. Now you can see at the starting of the situation, water is at 40 degrees centigrade, gradually falls to so-called 0 degrees centigrade. Thereafter, no further fall, but ice keeps melting. What to understand from this particular situation? See, the total picture is for 40 minutes. So in 40 minutes, temperature of water fallen from 40 degrees centigrade to 0 degrees centigrade. That you can write it as P is equal to, P is equal to ms delta T by T. That you can express it as how much is the quantity? 0.6 kg sample. 0.6. Here they have given specific heat as 4200 and the temperature difference is 40. Remember, all this happened in 40 into 60 seconds. That's the power. That is the power. So if you want, you can see that what's happening over here. The calculation part will works around 42 watt. Right. The value of power is the first question which I have successfully answered. Now the second part of the question deals with the initial mass of the ice in the container is equal to. Now, sample of the ice that has received heat at a constant rate free from water. So what happened initially is it is at minus 30 degrees centigrade initially. And in 60 minutes, it has come down to 0 degrees centigrade. So which means following from here, I can mention mass of ice, specific heat of ice, temperature difference by 60 into 60 is the same power. So mass of the ice is what you want. A specific heat ice they have given 2100. Difference of temperature 60 by 60 into 60 is power 42. So on solving this, you will get the mass of the ice as 2.4 kg. A simple substitution. See, both informations I got it from graph only. What is the objective of the graph? Temperature difference and time was clearly mentioned in the graph. Right. The mass of the ice formed due to conversion from the water till thermal equilibrium is reached is equal to. See, after 60 degrees, we have attained thermal equilibrium, and that equilibrium is 0 degrees centigrade. Now, what is happening is ice conversion takes place. Now, till here, water came down to 0 degrees centigrade. So, what's happening over here there? Ice conversion takes place in this 20 minutes. Means some water is converting. It is a freezing to ice. 40 minutes to 60 minutes. Right. Now, what amount of water formed? M water, latent heat of fusion of ice is P into minutes 20 into 60. I'm assuming whether it is true or not, that is none of my business. It's mentioned in the question. So the mass of the water converted into ice is 42 into 20 into 60 by, that is also given here. That is also given here. Note this. 3.3 into 10 to the power of 5. And this will be 2.4 kg. Oh, hold on. Sorry. That is already taken for, sorry, the calculation part. After doing, you will get it as 0.15 kg. This is 0.15 kg. Okay. So that's the deal. That is about this graph based question. Now we'll proceed further. Some of these questions we have already done. So this is the next question which we are supposed to deal with. You have a teapot of mass. What you have is 500 grams and an insulating thermos flask are in a 20 degrees centigrade room. The teapot is filled with 1000 grams of boiling water. Please note it's boiling water. Unless or until mentioned, it is at 100 degrees centigrade. Tea bags are then placed into the teapot. A brewed tea is allowed to cool to 80 degrees centigrade. Then 250 grams of the tea is poured from the teapot into the thermos. The teapot is then given, it is then kept on an insulated heater that transfers. So you have this 5 grams of water at 30 degrees centigrade and 5 grams of ice at minus 20 degrees centigrade mixed together in a calorimeter. Find the final temperature of the mixture. Assume the heat capacity of the calorimeter to be negligible. Specific heat of ice and water are respectively given. Fine, no issues. See, you have 5 grams of water at 30 degrees centigrade, 5 grams of ice at minus 20 degrees centigrade. See, please try to understand. First, this is the beaker. See, 5 grams ice From minus 20 degrees centigrade to 0 degrees centigrade requires 5 into 1 by 2 into 20, 50 calories. Right. Next, whether it melts or not, that's a different story. Now come back to donor. 5 grams of water, 5 grams of water, when it comes down to from 30 degrees centigrade to 0 degrees centigrade. So it will lose 5 into 1 into 30, 150 calories. So no initial estimation 50 calories. So it can give more. Means some ice will melt. Now, how much ice will melt? That we will work on right now. So 50 calories plus some mass of ice into 80 is equal to 150, which implies mass of the ice melted is 100 by 80. 100 by 80, 5 by 4, 1.25 gram. So finally, what happened is that, assuming this is the picture, finally, you have ice of 3.75 gram, water. How much water? 1.25 plus 5, 6.25 gram, and both coexisting means at 0 degrees centigrade. So the final temperature of the mixture is 0 degrees centigrade. Right. So move on to the next question. A flask has 200 grams water at 70 degrees centigrade. Ice at 0 degrees centigrade is continuously added to it and the mixture is stirred. After 50 grams of ice has been added, the mixture has only 40 degrees centigrade. A further 80 grams ice is added and in equilibrium, the temperature is recorded as 10 degrees centigrade. Good. Lot of information is there in this. Let the water equivalent, we will call W as water equivalent of flask. Let W be the water equivalent of the flask. The water equivalent of the flask. Right? Latent heat of fusion B ice. What do you want? Water equivalent of the flask, latent heat of the, let LF related to latent heat of fusion of ice. Right. Now, what is happening here? Heat gained by ice is heat lost by water and flask. Heat gained by ice 50 into L. Heat lost by water. Heat lost by, there is heat gained by the house and heat lost by the water and flask. One more important point, you said another important point is ice at 0 is added continuously. 50 grams of ice has been added. The mixture has only water at 40 means ice melted. That also you need to consider. So which means This is a 50 specific heat, 140. This is totally gained. Heat lost 200 grams into 1 into 70 minus 40 plus W into 70 minus 40. So this gives one equation with two unknowns. You have 50L plus 2000 is equal to 6000 plus 30W. So finally, you will have 5L is 3W plus 400. Let this be equation 1. With this data, till this point, I cannot solve the question because only one equation is possible and there are two unknowns. A further 80 grams ice is added and the equilibrium temperature is recorded to be 10 degrees centigrade. What is happening now is you have totally water of 250 grams at 40 degrees centigrade. So gain part is again 80 into 80 is equal plus 80 into 1 into delta T, 10. This is again gain part. Oh, sorry, I don't know 80 because basically I've written it as 80. I don't know this. That I need to find 80L. Right. Next, on the other side, there are 250 grams of water at 40 degrees centigrade is now coming down to 10. 250 into 1 into 40 minus 10. Right. Of course, W into 40 minus 10. Now, solving which you will get one more equation. 80L plus 800 is 250 plus W times 30, by which you can add one more equation as 8L is 3W plus 670. Equation 2. Done. To solve both, you will get L as well as W. So equation 2 minus equation 1 gives 3L is 670 minus 400, which is 270. So L can be written as 90 calorie per gram. You have L, substitute in any one of the equation, you will get W, and you will get W as 50 by 3 gram. A good question, honestly. Next, 19th question. In 19th question, you have 80 grams ice at minus 15 degrees centigrade is taken in a container of negligible heat capacity. It is supplied heat at a constant rate of 10 calories per second till the entire ice becomes steam at 100 degrees centigrade. Plot a graph of temperature T versus time. Okay, fine. We know this. Remember, in this, your ice initially is at minus 15 degrees centigrade. First, 80 into 1 by 2 into difference of temperature 15 is the initial process of taking heat, which you said it is 10 calorie per second into time. By the way, it is 40. It takes, let this be T1. It takes 40 for 15s, 60 That part is 60 seconds. I repeat, 60 seconds. So 8 grams specific, I think there's a problem. They are given 0.53 calorie per gram. So you cannot go directly. Hold on. I need to work again on this because I took it as simply half. Right. I work on this again. Sorry. It is 8 into 0.53 into 15 is you are supplying a 10 calorie per second into T1. In this, 8 into 0.53 into 15 divided by 10 gives 6.36. 6.36. Hold on. Then ice melts means 8 into 80 is equal to 10 into T1. So remember, this is an interval. So when I write T2, T1 dash, for example, it is a T1 dash plus T1, which is 64 plus 6.36. That is 70.36. I repeat, ml is 10 T1. The T1 is 64, already 6.36. So this works around 70.36. Or likewise, so this is one interval T1. Next. So likewise, you need to work. This is a T1. This is a T2. This is a T3. This is a T4. That's all. Intervals delta T1, delta T2, delta T3, likewise. So this is how you will work. So the first interval T1 we got as 6.36 seconds. The second interval we got a T2, of course, delta T1 is 60, 64 actually, 64, 64. So finally, adding 64 and 6.36, you will get the T2 as 70.36. And thereafter, it is water at 0 degrees centigrade. And now I am calculating delta T2, and that is 8 into, by the way, what is the specific 8? 1, fortunately, into 100 by 10. So that is 80. 80 is to be added to 70 points. So T3 is T2 plus delta T2. So 80 plus 70.36, that is 150.36 seconds. And T4 is what we want. T4 is T3 plus delta T3, and that is 150.636. Delta T3 is entire 8 grams to vapor. So 8 into 539 by 10. Trust me, you will get this as 431.2. So overall, this is 581.56. Okay, this is 100 degrees centigrade and this is 0 degrees centigrade. That's all. Next question. This is a famous formula which we have already derived. Don't forget. Yesterday, in our previous class only, we have derived. The same question which we have already done. It's a direct formula based. The temperature of equal masses of three different liquids. A and B are mixed thoroughly. The final equilibrium temperature is 16. You know what is the meaning of this? T equilibrium 1 is you mixed A, M into specific heats SA into 12 plus M into SB into 19 divided by M times SA plus M times S. This will allow you to frame one equation. So this allows you to frame one equation, and that equilibrium is also given as 16. This allows you to frame one relation, and that relation is SB is equal to 4 by 3 SA. Similarly, the other equation is also possible for you. On mixing B and C, the final temperature is 23 degrees centigrade. So 23 is, are now we know masses are same. On mixing B and C, so SB into 19 plus SC into 28 by SB plus SC. Now you will get some relationship in terms of B, which means you can write SC as 4 by 5 SB. What will be the final? You are mixing now A and C. You don't want B now. So equilibrium temperature is SA into 12 plus SC into 28 SA plus SC. But so uh, you will convert everything in terminology of B. Otherwise, yeah, that is the only opportunity for you. SA is 3/4 12 times SB. SC 4 by 5 times 28 SB by SA 3 by 4 SB plus SC 5 by 4 SC SB. No, 1 minute. SC 4 by 5 SB. So solving which you will get the value as 20.26 degrees centigrade. Right.